Graphing parabolas in which the quadratic is in general or standard form. Our objective, we want to graph quadratic functions, and we know that graph is a parabola when the function is written in general or standard form. Okay, let's take a look at what we know here. We know what a quadratic function is. Any function of the form f of x equals ax squared plus bx plus c, which, by the way, is the general or standard form. So let's just make a note of that here while we're here. This form is the general or standard form. It's the form we usually see. And we know that a, b, and c are real numbers, and a cannot be 0 because we need a squared term in order for it to be a quadratic. And we saw in a previous video what parabolas were. They are the graphs of any quadratic function. And we know that they are shaped like a bowl or an upside down bowl, depending upon the sign of the leading coefficient of the coefficient of the x squared term. If the a is positive, the parabola opens up. If the coefficient is negative, the parabola opens down. We know that they are symmetric with respect to a vertical line, which is called the axis of symmetry. And we know that it has a vertex, which is where the parabola makes its turn. As it turns from going down back to up, you have a vertex. That low point is called the vertex. Or, as it goes up and back down, that high point is called the vertex. Okay, keeping this fairly simple, as we noted before, this is the general or the standard form of a quadratic function, ax squared plus bx plus c. And as we know, the a cannot be 0 because you need to have an x squared term in order for it to be a quadratic. We noted before, the graph opens upward if a is greater than 0. The graph opens downward if a is less than 0. This is some new stuff here. The coordinates of the vertex can be found from the general form. The x-coordinate is the opposite of b over 2a. Well, there's b and there's a. And the y-coordinate is the value of the function at this value, at negative b over 2a. It'll make sense when you see an example of this, but this gives you the x-coordinate. You find this, you run it through the function to get the y-coordinate. And of course, because the x-coordinate of the vertex is the highest point or the lowest point, okay, the equation of the axis of symmetry is simply x equals that x-coordinate right there. Okay, and we'll see that too in our example. Okay, so to graph a quadratic function that's written in this general form, we first determine, does the parabola open up or down? We second determine the vertex. We find the x-coordinate by substituting b and a into here. And then we take the x-coordinate we calculated, we put it into the function, and we get the y-coordinate. We then calculated any intercepts to help us. And then we can plot those points and connect those with a smooth curve. And I'll put in parentheses here, we can also use the axis of symmetry to assist in that plotting, because we're going to know it right here, excuse me. Okay, so let's do it. Probably a little bit, maybe a little bit easier than you might think, or not so complicated. But as usual, it's nice to have an example and kind of follow it through. So I've got a quadratic function here. I want to graph. Example 1, the function is the opposite of x squared minus 2x plus 1. Okay, so let's make a note because we need to know a and b. Well, right here is a, the coefficient of the x squared term. A is equal to negative 1. And right here is b, the coefficient of the x term is b, and so b is equal to negative 2. Now, of course, we know that c is positive 1 but that doesn't come into play when it comes to graphing this using intercepts and the vertex. So 1, we said, does it open up or down? I'm going to make a note of that. Does this thing open up or down? Okay, well, a is equal to -1. The coefficient of the x squared term is what dictates whether it opens up or down. -1 is less than 0. So the parabola we're going to graph opens down because that coefficient is negative. Number 2, we got to find the vertex. Okay, well, the vertex is found by the x-coordinate is -b over 2a, and the y-coordinate is the function's value at -b over 2a. That's the vertex. So let's see. -b over 2a is equal to negative. Well, b is -2, and you know me, I like to use parentheses so I don't lose negatives. Over 2 times a, and of course a is -1. Let's see here. This is going to be, these two negatives will cancel. I have 2 divided by -2. And that comes out to be -1. So this is the x-coordinate of the vertex of our parabola, the graph of this quadratic function. So now this is the x-coordinate. I'm going to put this into the function and come up with the y-coordinate. So I know that f of x is equal to -x squared minus 2x plus 1. I'm simply copying this. I need to come up with f of -b over 2a, right? F of, well, -b over 2a is equal to -1. I just calculated that. So that's equal to f of -1. So I'm going to put -1 into here. I have a negative sign, don't lose it. And I'll put the -1 in parentheses and square it. And right here is where students will get lost with these double negatives. Subtract 2 times -1 and then add 1. This can go into a calculator. Let's see, I can do this by hand, I think. That's 1, so this is -1. -1 plus 2 is +1 plus 1 is 2. So there's 2, and this is the y-coordinate of the vertex. So our vertex is at -1. Got to catch my mistakes as best I can. -1, 2. Okay, now let's find intercepts. Where does it cross the y-axis? Where does it cross the x-axis, if indeed it does? So number 3 was intercepts. Let's do the y-intercept first because it's the easiest, because that's when x is equal to 0. Okay, so my function says I'm going to use y instead of f of x to make my life a little bit easier. Y is equal to -x squared minus 2x plus 1. I'll put a 0 in for x, -0 squared minus 2 times 0 plus 1, and y is equal to 1. So it crosses the y-axis where y is equal to 1. My y-intercept is the point 0, 1. Okay, that's the easiest one. You just pop in 0 for x and out comes 1, and that's pretty clear from right here. 0 minus 0 plus 1. The x-intercept or intercepts is a little bit more difficult, and in a quadratic it might require using the quadratic formula. So the x-intercept or intercepts, which we know is when y equals 0. Okay, well, I want to find out when does -x squared minus 2x plus 1 equal 0. That's my question, right? I got to solve for x. So let's first off, I'll multiply both sides by -1. I want a positive x squared. So x squared plus 2x minus 1 equals 0. And then I'm hoping this is factorable, but it turns out it's not factorable. So I got to use the quadratic formula. So not factorable, darn. Means we're going to have to go to the quadratic formula to come up with the x-intercepts or their approximations. Okay, so that means x is equal to negative b plus or minus square root b squared minus 4ac, all divided by 2a. And now let's do some substituting. Turns out we needed to know c after all. Way back up here I mentioned we didn't need to know c yet. We need to know c because in this case, we need to use the quadratic formula. Okay, so b, I'm here because I multiplied both sides by -1. So here's my a, my b, and my c. So the opposite of b is -2 plus or minus the square root. B squared is 2 squared minus 4 times a is 1, times c is -1. That's all underneath the square root. All that divided by 2 times 1, 2a. Now, since I'm looking for the approximate answers, I'm just going to put this into my calculator. -2 plus this square root divided by this. And so x is approximately equal to -2.4, or -2 minus this divided by this. X is approximately equal to 0.4. I'll let you do that. -2 plus the square root of all this stuff, all of that divided by 2. -2 minus the square root of that, all of that divided by 2. And you should get those two numbers as approximations. So now we know a lot, okay? We know it opens down. We know where the vertex is located right here. We remember that the x-coordinate of the vertex means the axis of symmetry has an equation, which is x equals -1. That's the axis. This is the vertex, so the x, that's the top or the bottom. In this case, it's the maximum. So that's the axis of symmetry, x equals -1. We know the y-intercept, and we know it has two x-intercepts. One of these is at -2.4, 0. One of these is at 0.4, 0. So step 4, we can graph. I'll do my graph right in this space here. And let's see how I do with the space I have left on this paper. I'm going to label it. I may not be perfectly accurate. Okay, it opens down. We know that's going to happen. So we're going to be opening down. Our vertex is up here at -1, 2. So I'm going to go up to here, and I'm going to go to -1, and I'm going to go up to 2. This is 2, and that's my vertex right there. And I know that that is my axis of symmetry. It goes right through the vertex. So there we have it. Okay, and for some reason it's like I got a little bit, there we go. I got a little bit foggy there for a second. Let's clean it up a little bit there. Okay. Now, my y-intercept is at 0, 1. 0, 1 is here. Okay, so there's my y-intercept. I have two x-intercepts. One of them is at -2.40. Well, there's -2, there's -3. I'll ballpark that right here. That is one x-intercept. The other one is at 0.40. So here is 1. I'll ballpark 0.4 approximately here. And this is the second x-intercept. I have 2. And now I can connect those with a smooth curve. Again, I know this is the top, and I know this side is symmetrical to that side. So I'll come down like this, and I'll come down like this. And I have just graphed that quadratic function. It is an opening down parabola that looks like that. So take your time, go through the steps there and work your way through it, and you should be just fine.